Hi everyone and welcome back to PrepFusion. I am Anish and today we will start with the lecture 51 of synchronous machines. So today we will discuss about electrical power, output and input for alternators. Okay, we will understand about motors in the next lecture. Today we will discuss specifically about alternators or generators, and we will obviously solve few questions on that. So the important point to understand, because in the previous lecture I told you to trust me on this delta, that this delta actually has a very important significance. So today we will understand what significance does this delta or the power angle hold basically. Okay, so I will solve this basically. I will solve this. So if I solve this here, my like I first of all I want to understand what is the power output of the generator. So power output will be here, right? This will be the power output at here, correct? So power output basically what is the power that the load is receiving. Okay, that I want to figure out. What is the power that the load is receiving, that I want to figure out. What will be that? That will be simply the terminal voltage Vt into Ia conjugate. So this current will be Ia, that will be flowing from the generator to the load. So here, right, I should not have written this like this. I should have drawn it like a cloud kind of thing, where the cloud is basically a load. Okay, cloud is basically a load. Okay, and the potential here is V angle 0 basically. This is the reference. Okay, so let me keep this down. Let me keep this at the top. Yeah. Okay, so I need to find out this value Vt Ia conjugate. What will be Vt Ia conjugate? So one thing I know, that what is my E angle delta? E angle delta will be again the same KVL equation, Vt angle 0 plus Ia vector format into Zs vector format. What is Zs? So Zs is basically Ra plus Jxs, or I can write it like this in vector format, or I can write this as magnitude of Zs angle theta s. Into theta s. Okay, so this is my Zs basically in vector format. What is my Ia current? So Ia current, if I want to write, right, the potential here is V, the potential here is E. So Ia current will be simply E angle delta minus, from here I can find out what is the Ia current, right? So from here if I want to find out what is the Ia current will be E angle delta minus Vt angle 0 divided by Zs magnitude into theta s. Okay, this is my Ia current. So what will be the power basically? This will be the electrical power output, right? PEOG. Okay, so first of all let me find out the apparent power. This is not electrical, this is not active power, this is the apparent power output of the generator at the load. Okay, so this is the apparent power. Out of this, only the real component will be the real power and the imaginary component will be the reactive power. Okay, so here Vt into Vt will be Vt only. Vt is just angle 0, V angle 0 into Ia conjugate. Ia conjugate will be what? If I conjugate on both sides, right, here what will happen? I have to conjugate. So one property you must know, I hope you know this. If I have a Z, that is Z1, like Z angle theta or something, right? Z is a complex number, that is Z1 plus Z2. If I try to do the conjugate of this sum, this will be Z1 conjugate plus Z2 conjugate. Very simple, right? Simply the individual terms will be conjugated, right? And if I have two ratios, if I am conjugating here, the numerator also will be conjugated, denominator also will be conjugated. So this is very basic complex numbers. This I hope you have already learned. I am not explaining it over again. So here just let me keep the camera a bit in front. So this will be Ia conjugate will be E angle minus of delta minus Vt, because I'm conjugating, right? Whenever you conjugate, the angle becomes negative, right? This will be angle of minus of 0, which is 0 only, so it won't make any difference. This will be 0 only, V angle 0, right? This will be V angle 0. So this divided by magnitude of Zs will not change. This will be minus of theta s. Okay. So now basically here, right, I will replace this. So this will be E angle of minus of delta minus V angle 0, that is V only, right? It is a real quantity, or V angle 0 I can write, and this will be Zs, magnitude of Zs minus of theta s. So I can individually divide this, right? This will be equals to the apparent power output of the generator. So the apparent power output of the generator of the generator will basically be equals to this V into E, basically angle of theta minus theta s will go in the top, so this will be theta s minus of delta divided by magnitude of Zs, and this will be minus of V square into angle of theta s, because if I get the angle in the top, it will become positive, divided by magnitude of Zs. So this is the expression for the complex power expression for the power output of the generator. Very simple expression, right? So do you have to remember it? No, you can derive it, right? It should not take you much time. So from here I can directly say what will be the real component. So what is the real component here? So what will be the POG, active power? So active power, right? Here what is the real component? Cos of this angle, right? Cos of this angle will be the real component. So this will be VE cos of theta s minus delta divided by magnitude of Zs minus V square into cos of theta s divided by magnitude of Zs. Okay, so this will be the real power, basically. Real power of the generator, output of the generator. Okay. Now what about the reactive power? Reactive power QOG will be equals to this same thing only, just here sign will be there. This will be sine angle of theta s minus delta divided by magnitude of Zs minus theta s. Okay. So the important fact to note here, like this is the active power output and this is the reactive power output. The important fact to note here, generally what happens, your Zs is equals to Ra plus Jxs. Generally, because if the load is lagging, what will happen? Because your Zs is like a variable factor. So in case of lagging load, for lagging load, we know synchronous reactance increases by a lot, right? For lagging load, Xs goes to a very high value, right? If Xs is very high value, what will happen? Basically, your tan theta s, right? Tan theta s will be Xs divided by Ra will be very high, right? If this is very high, basically your theta s approximately will be equals to 90, approximately. Only do this approximation in case of lagging loads, or whenever your whenever your XS is very, very larger than RA, then only do this, right? Otherwise, don't do this approximation. If I do this approximation, what will happen? Theta S will be roughly equals to 90. So if theta is 90, this equation, right, the modified power output will be like this. If theta is 90, cos 90 is 0. So this is gone. So only this is left. So cos of 90 minus delta, which is sine delta. Right? So this will be VE into sine delta divided by. So if RA is very high, right? So what will be your magnitude of ZS? So your magnitude of ZS is equals to under root of RA whole square plus XS whole square. Now I have already told you that XS is very, very larger than RA. So your ZS also will be roughly equal to XS only. Okay. So this will be VE XS by XS. Okay. So this is the approximation that you can do. Okay. And I hope now you understand why is the delta angle and the power is highly related. If delta increases, then the power also will increase. Remember, this is for a lagging load specifically. I'm talking about lagging loads here. Okay. Other than that, like, or if XS is very, very high than RA, then only you can do this approximation. Otherwise, don't do it. Okay. That's why in the previous lecture I told you that delta and the power are related. So that's why it is called as the power angle. That's why it is called as power angle. Okay. So I hope you have understood this basic point. And reactive power also will be, you can, although you don't need to remember this, reactive power also will change basically. So okay, sorry, this will also will be sine, right? This will also be sine, sorry, sine theta is, right? So I hope you do understand, right? So the real component of this will be what? Basically I'm just adding the real components, that's it, right? Cos of theta s minus delta, cos of theta s, that's it. Okay, here because theta s is 90, so this will be the reactive power, and as theta s is 90, so this will be cos of delta, right? So this will be basically VE into cos of delta. Like, this reactive power formula is not that important. This is theta is 90, right? Yeah, cos of delta by ZS. ZS is almost XS minus V square by, this is sine 90. Sine 90 is almost 1. This will be XS. Okay. So this will be the formula of reactive power. Now you don't need to remember this, right? If you want, you can remember this, or you can derive it. It might take you a bit of time to derive it, but this, like this, you can directly write. Instead of following all this process, right, you can directly jump into this step, right? This step is the most important one. If you are able to write this, right, this line, then automatically you will be able to derive it. Okay, so just understand how am I writing this line, directly write this line, and from there you can solve this. Okay, you can solve this. Okay, so so yeah, so these are the formula for the electric power output. Now what about the electrical power input? Okay, electrical power input. So electrical power input will be what? So electrical power input, basically it is what is the input power to the generator. What is the input power to the generator? What will be the input power to the generator? Input power to the generator will simply be basically how much power I need to give to the generator, right, with the prime mover that I want to know. So how much power? So power will be here, right? This will be the input power, basically whatever power I am giving here. So here what is the current? Current is same, current is IA only. So input power to the generator will be what? Or SIG, apparent power. From there I will write the active power. SIG will be what? It will be simply E angle delta into IA conjugate. Okay, so this will be Sig will be equals to E angle delta. What is I conjugate? Same thing, right? Same, this thing. This will not change, right? This is already I have told you. This will not change. So this will be E angle minus delta V angle 0. Okay. So from here, so this will be basically E square, and plus delta minus delta will be 0 degrees only. This will be 0 divide, okay, minus theta is also there, so this will be theta is only divided by Zs minus E, then this will be delta E into V into delta plus theta s divided by magnitude of Zs. Okay, this will be the input power to the uh, to the to the generator. This is the input apparent power to the generator. So from here I can directly, like, I can write this in a better manner. So what is the input power? Input power to the generator Sig will be E square into theta s divided by magnitude of Zs minus V angle E delta plus theta s divided by magnitude of Zs. Okay, so this is the input apparent power, but what about the real power, real active power and the reactive power? So input active power that I need to provide to the generator to produce that armature current will be like cos of this, right? It will be E square by magnitude of Zs cos theta s minus VE cos of delta plus theta s divided by magnitude of Zs. Okay, so this is the active power input to the generator. Okay, again you can do the same approximation. If you say that your theta s is, like, if your xs synchronous reactance is much larger than Ra, then your theta s will be approximately 90 degrees. Then what you can do, then your magnitude of Zs also will be approximately equals to xs only. So okay, let me first write down the full like values. So the reactive power will be E square divided by magnitude of Zs into sine of theta s minus Ve into sine of delta plus theta s divided by Zs. Okay, so yeah, now if I write down the approximate values, so what will be the approximate value? So approximately Pij I can write, if theta is almost 90, so cos 90 will be 0, so this will be the input power. So cos of 90 plus delta, cos of 90 plus delta is minus sine delta, right? So here is my cos, theta, and here is my sine theta. So if I'm adding 90 with cos, any value, angle, right, it will be minus of sine theta. So it will be minus of delta. So it will become positive basically. So this will be VE angle plus sine delta, and minus minus will become plus, divided by XS, right, approximate value. Only valid when my synchronous reactance is much higher than the armature resistance. And what about my Qij? So Qij will be again approximately, this is 90, right? So it will be E square by XS. This is 90. So this is sine of 90 plus delta. So what is sine of 90 plus delta? It will be cos theta only. So it will be basically cos of delta. So this will be E square divided by XS minus VE divided by XS into cos of 90 minus 90 plus delta, that is cos of delta. So E square divided by XS minus VE XS into cos of delta. Okay, so this will be the reactive power formula for the input to the generator if I approximate it, right? If I somehow approximate it, this will be the formula. Okay, approximately. If my XS is very larger than the XA. Okay, so remember all this, right, is per phase. Okay, whatever we have derived per phase. So what will be the three phase power? So three phase power, whatever we had derived is per phase, because induced EMF was per phase, everything was per phase. So three phase power, because it is a balanced load, right, will be equals to 3 times the per phase power. Remember this, right? Otherwise you will make a mess up in the examination. Very important thing. Per phase power. Okay, so these things are important. So I want you to try out few questions. You try out these questions. Okay, I will pause the like questions. You can try out this question, you can try this question, you can try this question, and this is the last one, 10 question. After this also there is few more topics left that we will obviously discuss, but these questions you try. So let's now solve this question, right? So let's solve this question. So a three phase 11 kilovolt star connected, it is star connected, is connected to turbo alternator. So every single thing that I teach you, right, is important. So we have already discussed what does turbo alternator means. Turbo alternator means basically, this means it is a steam power plant, right? Steam power plant, not hydroelectric, it is a steam power plant. Okay, it is a steam power plant with synchronous reactance as 6 ohms. So my XS is equal to J6 ohm, right? XS is 6 ohm basically, and negligible armature resistance. So armature resistance is negligible. So RA is 0, right? So basically my ZS is simply equals to J into XS, J6. That's it. Okay. So this is my circuit. I have infinite bus bar. So this is sometimes also represented as infinite bus bar. This is my terminal voltage VT, and this is my induced EMF E. Okay, angle delta. Now they are telling me it is connected to a unity power factor load. Okay, initially it is connected to a unity power factor load. So that means that the angle of current or theta basically will be 0. Okay, and delivers 200 amperes of current while connected to a constant voltage, constant frequency bus. So this is the bus basically. If the steam input remains unchanged, So in a steam power plant, the input is steam, right? What happens? Basically, it is air, right? I flow the air, and through that, the blades of the fan will rotate, or blades of the turbine, blades of the prime mover will rotate, right? So the more steam I will provide, the more faster the blades will rotate with more torque, right? They are telling me that I am providing the steam input to be unchanged. So the steam input is unchanged. It is not changing. So if it is not changing, that means the basically the input power of the generator is unchanged. So if initially the input power is pig to the synchronous generator, now the input power is pig dash. Okay, and pig dash is same as pig because the input steam is not changing. If the input steam remains unchanged, so the input power also remains unchanged. Okay, and the internal generated EMF is increased by 25%. But they are telling me in the second phase, if initially the EMF was E dash will be 25% increase. So it will be 1.25 1.25 of E. Okay, 1.25 of E. So determine the resulting armature current and power factor. So they are asking me initially the armature current IA was 200 amperes and the power factor was unity, right? Now they are asking me what will be IA dash and the power factor dash, right? These things they are asking me. So basic thing is like there are two ways. First one is to solve with the formulas, right? Formulas, okay, which we derived, and this is how you should also proceed, right? If you want to try with basics, it will take you forever. Okay, you can. Okay, so with formula I know the formula for power, right? What was the formula for input power, if you remember? So the formula for input power is quite different. I derived it for the output power. So what was the formula for the input power? So here, right, if I go back here, okay, yeah, okay, formula for input power actually remains same, almost same, because the resistance is 0. If Ra is 0, whatever I provide is as the input power, the same is as the output power. This I forgot to mention at that point of time. Just the reactive power changes, right? Reactive power formula you have to remember separately, but the input power formula is same. So basically here, right, if one more conclusion, these are the conclusions basically I forgot to mention. If if Ra is 0, then Pig is equals to POG is equals to VE sine delta divided by XS. Okay, this is one of the important conclusions. Okay, and one more thing is about the reactive power. So reactive power you have to remember anyways. So reactive power for this case will be V into E cos delta by XS, and it will be a negative here. It will just be the negative. If you observe, it is just the negative, just the opposite. So reactive power output to the generator will be this. And reactive power input will just be the opposite, right? It will be negative. So it will be V square. If you see, it is here, it is not V square, actually E square, just the opposite. Instead of V square, this will be E square by XS minus V into E cos delta. This will be same, just the opposite, right? Divided by XS. Okay, so this is the reactive power input, right? So these are the conclusions basically. So I will use it. So input power is same as the output power, right, which is equals to V into E sine delta divided by XS. So everything I have, I know what is the power, right? Power already I know. Do I know the power? Okay, I can find out the power, right? How can I find out the power? So power, right? I know it is unity power factor. So power will be root 3 into VL into IL cos phi, right? Cos theta is 1 basically. Cos theta is 1. So root 3 into 11 kilovolt into IL is 200 into cos theta. Cos theta is 1 simply, right? So this will be the power. Yeah, this will be the power, right? So I can write this over here. So my power will be whatever is this value, root 3 into V into 10 cube into 200. Now remember, here already there is a V, right? So this V and V will get cancelled simply, right? This will simply get cancelled, and basically your E sin delta, right? Because I don't know what is delta, I don't know what is E sin delta by XS is coming out to be this value 200 root 3. Okay, this is my E sin delta by XS. Now they're telling me, now what they're telling me, in the second case, in the case 2, they are changing your E dash to 1.25 times E, and they are changing the but the power, right, TIG dash is same, it does not change, it is the previous one. So previous power was what? Previous power was this value, correct, which is V into E into sin delta. But what is the actual formula of power, right? Actual formula of power is V into E dash into sin delta dash divided by XS. So basically the active power should not change, right? Active power should not change. When active power does not change, the terminal voltage is same, XS is same, so they will get cancelled. Ultimately, this, if active power does not change, then your E sin delta will be same. E dash sin delta and E sin delta dash will be same. This is a very, very important conclusion. Okay, don't need to remember it, but need to understand it. Okay, so like this is something familiar, right? This you will understand when you solve multiple questions. This will always come up. So basically your E sin delta will be constant if the input power is constant. Okay, so that is done. So basically I know what is my E sin delta. What is my E sin delta? E sin delta by XS is this, right? So if I multiply by XS here, E dash sin delta dash, E dash sin delta dash will be equals to E dash sin delta dash will be equals to 1200 under root 3. Now what I know what is E dash, right? Do I know what is E? Okay, I have to find out what is E. So from this equation, can I find out E? No, I cannot find out E from this equation. Any other equation I have. How can I find? Okay, how can I find out the value of E? So to find out the value of E, right, it's very easy. Use basics. So what is E? E will be equals to, like if I apply KVL here, basically E will be, E phasor will be basically Vt plus Ia into Jxs. Okay, so this will be Vt value I already know, that is per phase. Remember, it is star connected, so it has to be per phase. 6350 11 kilovolt divided by root 3 into Ia 200 angle 0, it is unity power factor, into J6, right? So from here I can easily find out what is the value of E. I can easily find out. So what will be the value of E? So E value, from here I can easily find out E and delta, both I can find out. Okay, so 6350 whole square plus 1200 whole square whole under root. So 62.4. Then what is delta? Delta I have to do the tan inverse, right? 1200 divided by 6350 tan inverse. So this will be 10 angle 10.7 degrees. right? So delta I know E, so easily I can replace over here. So so what will be sine delta dash? So sine delta dash will be basically equals to 1200 root 3 divided by E dash. E dash is 1.25 times the previous E value, which is this 6462.4. 6462.4. So this will be 0.2573. So from here I can easily find out my delta dash, but I don't need the delta dash actually. They have actually not have, they don't have not asked me to find out the delta dash. What I need to find out is I need to find out IA. What will be IA? Again I can use the previous equation, right? So IA will be E dash will be equals to VT plus IA dash angle, I don't know what is theta. This time I don't know what is theta, into J6, right? So my IA dash angle theta will be equals to E dash angle delta dash minus Vt divided by J6, right? So from here I can easily find out everything, every single thing. So basically my E dash delta dash, E dash is 1.225 times the previous E, that is 6, okay, this is E, right? Okay, this yeah, so E dash will be what, magnitude of E dash I'm talking about. So okay, I need the delta dash. I need the delta dash. So 2.73 sine inverse, right? This will be 15 degrees. So your delta 14.91 degrees, and and your uh, this, right, will be basically E dash. What will be E dash? So E dash will be 6462.4 into 1.25. Okay, sorry, not receive. 6462.4 into 1.25. 8078 volts. So I will replace it over here, right? I can solve it. So this will be basically 8078 angle 14.91 degrees minus 6350 divided by J 6, right? So this will be, if I want to, okay, if I want to find out this will be 8078 into cos of 14.91 7806 minus 6350. So this is 1456 plus this will be E dash sine delta dash, which will be same, which will be this value only, 1200 root 3. This will not change. So 1200 into root 3 into 1200. So this is plus J 2078.46 divided by G6, right? So this, right, if I want to calculate the angle 1456 tan inverse, this will be 55 degrees. divided by G6. So obviously angle will be negative, it is lagging. If angle is coming out to negative, right, I dash, IA dash, angle theta dash, so if it is lagging basically, divided by 6, right. So it will be, current will be 422.95. So current will increase here, and what will be the angle? Angle will be 90. So this will be 35, right, minus 35 basically. So the power factor, so my IA dash armature current will be 422.95 amperes, and the power factor cos of this, right, cos of this will be 35 cos theta dash will be 0.82 lagging, because the angle is negative, current is lagging from the voltage. Okay, so this will be the answer for this question. Let's now move on to the next question. Okay, so in the next question, again mostly like, what is the method 2? Method 2 is again going by the simple formula, KVL, KCL, all those things. Okay, so but I will not recommend that, because it's very difficult, like it will take you like the whole exam basically, you will not be able to come to the answer. So better is you remember the formulas. Okay, it's not that difficult to remember. Okay, so a star connected 11 kilovolt turbo alternator having synchronous impedance. Now they are telling me that synchronous impedance RA ZS is equals to 1 plus J10. So now RA is not negligible. Is connected to an infinite bus operating at rated voltage. The machine initially supplies an armature current of 100 amperes. Okay, so IA is equals to 100 amperes at unity power factor. Okay, so cos phi, cos theta is 1. The machine initially supplies an armature current of, okay, 100 ampere in unity power factor if the alternator excitation is increased by 15%. Okay, so alternator excitation is increased, maintaining constant power. So whenever they say excitation is increased, basically they are telling you that they are increasing the what, excitation voltage. That's it, they are increasing the excitation voltage. So E dash will be increased to 1.50 by 15%, right. So it will be 1.15 of the previous value. Okay, while maintaining a constant output power. While maintaining a constant output power, that means POG is constant, right. POG is constant, that means POG dash is equals to previous POG. Determine the new armature current, load angle and power factor. All these things we have to determine, right. So one thing if you remember, I will just write down quickly very few things. Okay, so what is POG basically? So I know what is POG. POG is VT IA conjugate, the real part of this. So let me first write SOG. SOG is VT into I conjugate, right. So what, if I write down the angles, so what is IA conjugate? So what is IA? IA is basically E angle delta minus VT divided by ZS angle theta S. So this conjugate will be equals to E angle theta S minus delta by ZS. Okay, magnitude of ZS basically, minus VT into theta S divided by magnitude of ZS. Okay, so this I will replace over here, right, because even though you will forget the formula, I can derive it in 10 seconds. Okay, I just want to explain how can I derive the formula in 10 seconds. So what will be my SOG? SOG will be this, VT is only VT V angle 0, so this will be V angle 0, so this will be V angle theta S. So this will become E into V angle theta S minus delta divided by ZS minus V square theta S divided by ZS. Okay, so this will be basically, I can say over here, what will be the active power basically, POG. POG will be EV angle ZS cos of theta s minus delta into minus V square into cos of theta s divided by magnitude of Zs. Okay. So even though if you forget the formula, still you can derive it within seconds. Still you can derive it within seconds. Okay. So what is cos of theta s, right? So cos of theta s will be very simple. So tan theta s is basically 10 upon 1. So that is 10. So theta s will come out to be, tan inverse 10 will come out to be 84 point, theta s is coming out to be 84.289. Okay, 289 degrees. So now I can replace, I have all the values, right? I have all the values. So what are they asking? They are asking me IA, right? So I know excitation has increased, so POG will be remaining same, right? If POG is same, then this will be equals to the new new POG with a new excitation. So this will be equals to E dash, because E has changed to E dash. V will remain same, V will not change. This will be ZS only. This will be cos theta s, of course, is theta s only. Delta will become delta dash minus V square by magnitude of ZS. This will be same. This will become cos. This will also be same, cos theta s. So what is changing actually? So E dash value I know. Can I find out E dash value? Okay, IA current is given to me. Yes, I can find out E. I can find out the value of E. What will be value of E? So value of E, again by using the basic KVL, E will be basically Vt plus J IA Zs, right? So okay, actually it is not J, IA into Zs. So Zs itself is phasor quantity, correct? So Vt is 6350, basically it is star connected, right? So it is a turbo 11 kilovolt, nothing is mentioned, right? I will assume it to be star connected. Okay, it is mentioned, right? It is star connected. Generally it will be mentioned. Okay, star connected 11 kilovolt. So basically I can say 6350 plus IA. Okay, IA value also I know, and it is unity power factor, operating at unity power factor. So 100 into 100 angle 0, basically 100 angle 0. And what is ZS? ZS is basically 1 plus J10, right? So this will be 6450 plus J 1000. Okay, 100 square plus 6450 100 square whole under root. So this comes out like my E comes out, E angle delta will come out to be 6527 angle. What is the angle? So angle will be 1000 divided by 636450 tan inverse, right? So this will be 8.81 degrees. Okay, this will be the angle basically. Now I know I have got the angle, I know the E, so I can replace, I know all the values. What is E dash? E dash will be 1.15 times the E, right? So E dash, magnitude of E dash will be 1.15 times of magnitude of E. So I will get 66527 into 1.15. So it will be 7506 volts. Okay, 7506 volts. Okay, so this is my E dash basically. So Now, yeah, I will replace everything in this equation, right? I will replace everything in this equation. I know theta s, I know delta, I know everything. So this will be a task. Just bear with me. This will be a task. Okay, okay. One more. Okay, one interesting thing. This is constant, right? So this will anyways get cancelled. Okay. So at least one calculation got reduced. Okay, I'm grateful. I'm forever grateful to you. One calculation has been reduced. So basically this V and V also will get cancelled, right? So this V and V also will get cancelled. This ZS also will get cancelled. So a lot of calculation are actually getting reduced. So basically this E dash, right, will come here. So E upon E dash is simply 1 by 1.5. So that also is actually reduced. So actually I did not need to calculate this much. But delta anyways I needed to calculate. So that is required. So theta s is already I know. So ultimately this is the equation 1, right? So equation 1 I can rewrite equation 1. So equation 1 will become, this will be E upon E dash, which is 1 by 1.5. E upon E dash is simply 1 by 1.5, right? E upon E dash, this will go there, will be 1 by 1.5. Cos of theta s minus delta. So cos of theta s. So what is theta s? So theta s is basically, theta s is what? Theta s is basically 84.289. 84.289 minus 84.289 minus the delta. Delta is what? Delta I had just calculated 8.81 degrees. So equals to, this will be cos of theta s. Okay, anyways, okay, no, I cannot simply cancel the cos, that I cannot do. Cos of theta s is again 84.289, but minus delta dash. Okay, so this value will be what basically? So if I calculate this, right, 84.289 minus 8.81 cos of this divided by 1.15 and then cos inverse. So this is 77.47. Now if I take it on that side, this will be 84. Like this calculation I am expecting you are able to do. So the delta dash is 6.882. This is the new delta dash that we are getting. So this is the new power angle. Okay, now I got the new power angle. This is the one of the answers. What else they have asked? They have asked the current. They have asked the armature current, right? How, what will be the armature current? So armature current is very simple. Ia dash will be simply what? E dash delta dash minus Vt divided by Zs theta s. Correct. So what is E dash? E dash is 1.15. So it is 7506 angle 6.882 minus Vt is 6350 divided by magnitude of Zs, which is under root 101. Angle is 84.289. Angle is 84.289. Okay, so this will be cos into 7506. So 7451.92 and minus 6350 plus this, right, 7506 into 6.882 into sine, this will be J 899.4. So this will be equals to basically this whole okay, let me not do this. 7451.92 minus 6350 whole square plus 899.4 whole square under root. So this is actually 9061 0.25 angle. So 7451.92. Okay, hold on. So this will be okay. Isn't it two? Okay, this cannot. Okay, I am doing something wrong. Sorry. 7451.92 minus 6350 whole square. So this is 11. Okay, this is actually, this value is 1101.92. Okay, plus 899.4 whole square. Okay, this is wrong. This is 1422.37, and so what is the angle? Angle will be 899.4 divided by 1101.92 tan inverse. So this will be 39.22. So this will be under root 101 angle 84.289. From here I will get everything. I will get the current and the power factor angle. So this will be Ia dash theta dash, right? So this will be here. If I want to write this right will be 39 minus 84.289. So this comes out to be, theta dash comes out to be minus 45, which is basically, it is lagging. It represents, it is lagging, and power factor, right? Power factor will be 0.707 lag. What about the current? So current, right? I dash magnitude, if I want to write the I dash magnitude, it will be 1422.37 divided by 101 under root. So it comes out to be 141.53 amperes. Okay, so it will be 141.53 amperes. This will be the answer of this question. Pretty straightforward and easy to understand. Okay, I hope I have done everything correctly here. Yes, everything is done correctly over here. Okay, so now yeah, this question is done. So now let's move on to the next one. Next one is this one. So in this question, basically, in this question we have to a star connected turbo alternator with a synchronous impedance of Zs is given here. Okay, again it is not zero, so I cannot simply use the formula. Okay, use the simple formula, and it's supplying Zs is, it is a star connected, Zs is 0.5 plus J10 armature current is 200 ampere, supplying at unity power factor. So this will be 0 degrees basically, to an infinite 11 kilovolt bus. So Vt will be 11 into 10 cube divided by root 3 angle 0. Okay, if the field excitation is increased by 25%, so E is increased by 25%, so the new E dash is 1.25 of the previous one. Determine the new armature current and power factor at which it will operate. Okay, assuming mechanical power input and efficiency to remain constant, it's the same question only. Okay, not like the okay, it's the same only, right? It's the name, it's the same only, mechanical power input, right? Mechanical power input is okay, this time it is different because now the mechanical power input is constant, not the output. Okay, the input is constant, so it's not quite the same. So again, now I have to find out the input power, right? So what is SIG? So what is again IA? IA will be E angle delta minus VT into ZS. Okay, so So what will be Ia conjugate? Ia conjugate will just be E by magnitude of Zs theta s minus delta minus Vt V divided by magnitude of Zs angle of theta s. Okay. So I can write over here. Now the what is the input power to the generator? So here, right, have I written it perfectly? Yeah, this was the output power. Remember, input power will be different, right? Input apparent power will be what? It will be E into Ia conjugate, not Vt into Ia conjugate. That is the difference, right? So E is basically E angle delta, right? And Ia conjugate is this value, right? So it's not like I'm remembering the formula. I'm also deriving. Every time I'm doing it, I'm deriving, and that's fine. That is fine. Like this question will take you a bit longer, but it's impossible for you to remember the formula. That's like a headache to you. I also don't want to remember the formula, right? So here, from here I can easily identify what will be basically this will be E square into angle of theta s minus delta plus delta will get cancelled Zs minus this will be EV divided by Zs into this, right, minus Zs. Yeah, this will be angle of delta plus theta s. Am I correct? Am I doing something wrong? Because this should have been, I think, this. Okay, this is theta s plus delta. Here did I do something wrong? Here, right, I was remembering something. Did I do something wrong here in the derivation? No, this is correct only, right? Yeah, this is plus only. That's correct. That's correct. Okay. Because here, right, this was this was as this was 90. Okay, yeah, this is correct only. This is correct. Okay, so that's what I was thinking. I was also getting. I also don't remember the formula. I also don't remember formula. Okay, trust me. I am very bad at remembering the formulas. Okay, so yeah. So now what will happen here? This will be so now what will be the output power? What will be the input power basically? Input power. Input power will be Zs cos of theta s minus this will be E into V divided by Zs into cos of delta plus theta s. Okay, now I can replace all the values here. Can I? So basically they're telling me that the mechanical input power will remain same. If the mechanical input power is same, this will be equals to the new, like the new value will be E dash and delta dash. So it will be E dash whole square divided by magnitude of Zs cos of theta s, this will not change, minus this will be E dash V by magnitude of Zs. Okay, now things will not simply get cancelled. Okay, okay, this is difficult. Things will not simply get cancelled, but still Zs will get cancelled, that is for certain. V, okay, V also will not get cancelled. Okay, that is sad. V will not get cancelled, right? So we have to solve it with the hard way. So first of all I have to find out magnitude of E, right? That is the most important portion. So whenever I write E here, right, that basically means it is magnitude, because phasor is angle is already factored in. Angle is already factored in. Okay, so E will be Vt plus Ia Zs. Okay, so Vt is 63 per phase 50 plus Ia is I guess 200 or something, right? Ia was 200, yes, 200, and Zs, right, Zs is what? Zs is basically this 0.5 plus J10. Okay, so this will be 6450. I think it is the same only, but okay, this will be J2000. So now from here I can directly find out 2000 whole square plus 6450 whole square whole under root. So this will be 6753 angle. What will be the angle? Angle will be 2000 divided by 6450 tan inverse 70.227 degrees. Okay, so okay, so basically so my delta will be 17.227 degrees and my magnitude of E will be 6753. So E dash will be what? I have increased my excitation by 25%. Okay, so I've increased my excitation by 25%, right? It is 1.25 of the previous one. So my E dash will be 1.25 times the previous excitation. So 6753 into 1.25, so it is 8 4.1.25 volts. Okay, so yeah, so this is the magnitude basically. That's done. Now yeah, so now I can replace in this equation 1 again, right? This is my equation 1. I can again replace in the equation 1 everything. So this will be here will be a bit difficult. It will be difficult. So E dash whole square, E whole square, so this is 6753 whole square divided by magnitude of ZS. Magnitude of ZS is basically, okay, ZS will anyways get cancelled. This will be cos theta s. Cos theta s is what? Cos, this is also cos theta s, right? But this is E dash whole square. So basically this will be E whole square minus this, right? Okay, I have to find out this delta dash. So what I can do is I can take this on the left hand side, I can take everything else on the right hand side. So this will be 844.25 whole square. Into cos of theta dash. What is cos of theta dash? So theta s is have we calculated? We have not calculated the theta s. So I will calculate quickly the value of theta s. So this will be tan inverse of 20. So that is 87. Almost, it is like almost purely inductive only. We could have done it with approximation as well. Okay, there would not have been much difference, but still for the convenience, because it is a NAD type, if it was option, right, if it was multiple choice, I could have solved these using the basics. I will show you how much difference we will get if I just simply neglect the armature resistance. I will show you that as well. Okay, so what will be cause of this? Cause of 87 point, this will be 0.05. Okay, and this will be, if this goes on the right hand side, if this goes on the right hand side, what will happen? If this goes on the right hand side, it will be simply added, right? So E into V delta plus E, that is 6753 into V 6350 divided by okay, ZS is anyways cancelled, into cos of theta plus delta. So theta is 0 anyways, So this will be same only, sorry, cos of theta s into delta. Okay, delta is not 0, sorry, delta is not 0, right? Delta is 8 point some value, so delta is 17 point something. So this will be cos of 17.227 plus uh, plus this angle 87.1376. This is equals to this, right? Basically magnitude of this, so E dash V by ZS, so E dash into V, E dash into V. So E dash I know what is the E dash value, 8441.25 into V also I know what is V. V is 6350 into cos of theta dash plus theta s. Okay, delta dash plus theta s. Delta dash is 17.227 plus theta s. Theta s is, okay, sorry, delta dash, right? Delta dash I don't know what is delta dash, plus theta is 87.16 degree. Okay, so from here I know this is a big calculation, but this is the maximum that they can ask, that I'm going to. So here, right, this we have to solve. Okay, let's solve this. Let's solve this. This will be hectic. So 8441.25 whole square minus 6753 whole square into 0.05. So this will be 12828584.63 plus 17.227 plus 87.16 cos of this. Okay, this will come out to be negative. Okay, automatically this will come out to be negative, even though this term, right, is going on this side, it is positive, but this is higher than 90, so this will become negative actually, into 6753 into 6350. Okay, so which is quite large, to be honest. Okay, now if I add this with this value, right, this will plus 1282,584, 1282,584. This is coming out to be negative. Okay, it is coming out to a negative, that is fine. Now I have to divide this by these values, right? So it will be divided by 8441.25 into 6350. I'm just doing calculation. So this value is coming out to be minus 1.75 equals to cos of this value, delta dash plus 87.16 degree. So now if I do cos inverse and if I subtract 87.16, right, it comes out like delta dash is very very near to the previous one only, 12.9 degrees. Okay, so previously your basically your angle was for how much, delta was 17.72, now your delta dash is 12.9 degrees. Okay, what have they asked? They have asked us the new armature current and the power factor, right? So armature current will be what? Again we have to solve this. Armature current, right, IA vector will be again very simple, E dash delta dash minus Vt divided by Zs theta s. Okay, so E dash I know that is 8441.25 into delta dash, right? So delta dash is 12.9 degrees minus Vt is 6350 divided by Zs. So Zs, magnitude of Zs will be what? Magnitude of Zs will be this 10 square plus 0.5 whole square, that is under root 100.25 into angle of theta s. So theta s will be this, theta s I already know, that is 87.1376. So 8466, so if I calculate this values, right, so the numerator I want to calculate 8441.25 into cos of this, right, minus 6350, so it comes out to be 1878.2 and plus 8441.29 into 12.9 into sine, so this will be 884. This is almost like what do you call, uh, 707 power factor, right? So it's like 45 degrees. So this will be plus j. So this whole square plus 1878.2 whole square whole under root, this comes out 2660. Okay, so this will be 2660 angle. So this angle will be tan inverse, so 45.1 degree divided by 100.25 under root 10. Okay, uh, 10.0125, 87.14 degree. $87.14 plus 45, so this will be 42 minus 42.14 degrees. So the power factor will almost be like almost be 707. So cos of this, right, so power factor will be 0.7415 lag, and the magnitude of the armature current, new armature current, will be 265.732 amperes. So armature current will be 265.732 amperes, and this will be the power factor. Okay, now if I approximate it, okay, if I use the approximation, right, approximation, what kind of approximation? So if I tell you my Zs is roughly equals to Xs only, Jxs, right, I neglect the armature resistance. So what will happen? Then I can directly write that my E dash EV sine delta by Xs is equals to E dash V Xs into sine delta dash, right? So uh, what will happen is I know what is E dash V, okay, everything will get cancelled. Do I know sine delta? No, I don't know what is. So my sine delta dash will basically be equals to, because E dash is 1.25 times the previous one, so it will be 1 by 1.25 into sine delta. Now what is sine delta? What is sine delta? I have to find out, right? How can I find out sine delta? So to find out sine delta, you have to again find out the armature current, or you have to find out the E, right? E angle delta will be basically equals to this Vt. I am neglecting the armature resistance, so this will be J into Xs into Ia. So Vt is 6350 plus J is basically angle 90. Xs is 20, right? 20 or 10? Is it 20 or 10? Xs is basically 10. So it will be 10 into plus 90 That's it, right? I guess that's it. 10J into X, IA is 200, I guess. IA is 200, correct? Previous current was 200 amperes. If I remember it correctly, yeah, 200. So this will be simply uh, into 200. So directly I can tell you what will be the E and delta, right? So this will be 2000 whole square plus 6350 whole square whole under root. Okay, so this will be 6353. This will not change much, right? Magnitude will not change much. Okay, previously what was the EMF that I was getting? So previously, if you see, okay, the EMF was quite different. So you cannot simply, am I doing it correctly here? Let me check once. So 2000, this should change actually, plus 6350 whole square whole root. Yeah, that is what I was thinking, right? This changes 6657.51. And what is the uh this delta will be 2000 upon 6350 tan inverse, so 17.48. Now if you observe, right, here I was getting what, with exact I was getting 6753. Okay, I was getting 6753 and this 17.227. So yeah, this was kind of wrong, right? This was wrong, but your delta is almost to the point. Your delta, if you see here it was 17.227, here also it is 17.48, almost to the point. So this you can only apply when options are there and they are very far. So you can use this, right? And generally the questions will be option type only. I am giving you NAT just for the worst case, but options are very far, right? Then you don't need to do all this, right? Don't need to do all this. Approximately you do the calculation and the near about answer will be your answer. Okay, so now we can simply find out, right? You know what is delta dash, so I can simply find out what is the new power angle, sine delta dash. Sine delta dash will be 1 by 1.25 into the previous one, so sine of this, right, it will be 0.3, so divided by 1.25. Okay, so sine of this, so your delta dash, new delta dash coming out to be 13.9, and previously it was coming out to be 12.9, something like that, right? If I remember, here it was coming out to be, yeah, 12.9. So yeah, roughly there will be bit of changes, but like see how fast it is, right? How fast it is. Okay, so again you can approximate the armature current here. So what will be the armature current? Armature current will be E angle delta, E dash angle delta dash, minus Vt divided by J xs, right? So this will be Ia dash, this will be equals to 6657.51, sorry, into 1.25, because it will be increased by 1.25. Angle will be 13.9 minus Vt 6350 divided by, okay, so xs is angle 90, right? 6657.51 into 1.25 Ia dash. So here basically this will be into 13.9 cos of this, right, minus 6350, this will be 93 minus, sorry, plus 13.9 sine of this into 8321 J, this value, plus 20. One seven two eight three 2642.56. Angle will be 1999.151 divided by 1728.153. So tan inverse of this, so this comes out to be 49.15 degrees divided by 10 angle 90. So this will come out to be 264.25 amperes, and this will be minus 90 minus 40.84, right? So this will be IA dash, and what will be the power factor? Power factor dash will be cos of this, which is 0.756 lakh. So let's see how much far away we are from the options, right? Answers. So previously the power factor we had, this was 265 and 0.741. It is 265, almost same armature current, and power factor is very, like, there is a difference but very negligible, right? So if options are very far away, then you can simply use this instead of doing all this, right? It's very hectic, right, to do all this. Do you understand how big of a calculation it is? So you can neglect that and directly solve using this one. Okay, so that is a shortcut basically that I am trying to tell you, right? Let's solve this next question. Okay, so these questions are actually taking a lot of time. So let's solve this next question. A 3-phase 11 kilovolt 5 MVA alternator has a synchronous reactance of 10 ohm per phase. The excitation is adjusted so that the internal generated EMF is 14 kilovolt. Okay. Okay. Excitation is okay. Okay. If the alternator is connected to infinite bus, what is the maximum power it can deliver under this excitation? So they are asking me what is the maximum power they can deliver. And again, if you observe here, the armature resistance is 0. So basically, what is the maximum power it can deliver under this excitation? So what is the power of the output power of formula? If the armature resistance is neglected, it is E V by XS sine delta, right? So what things have they fixed? They have fixed the excitation, so this is fixed. Obviously the terminal voltage will be fixed, right? It's 11 divided by 11 kilovolt divided by root 3. Excess is obviously fixed. What can vary? This can vary, right? Delta, power angle, can vary. Now they are telling me what is the maximum power it can deliver. The maximum power that it can deliver will be when the sine delta is maximum. When is a sine function maximum? When it is 1. The maximum value of sine delta is 1. So the maximum power that my generator can deliver is EV divided by XS. So E already they have given me is 14 kilovolt, 14 into 10 cube. Okay, this is the line voltage. They have mentioned it is the line voltage. So per phase voltage will be 14 kilovolt divided by root 3 into, remember, this is the line voltage. So this will be, again nothing is mentioned, so I will assume it to be star connected. 11 into 10 cube divided by root 3 divided by the synchronous reactance, that is 10. So your answer will come out to be 14 into 10, so 154 into 10 raised to power 6, okay, 15.4 into 10 raised to power 6 divided by 3. Okay, this will be your answer basically, and you will be wrong. Okay, why this will not be your answer? Why this divided by 3? Like one of this, in one of the options, basically 15.4 divided by 3, right? This 5.133 megawatt will be there, right? And this will be wrong actually. Why this will be wrong? So I told you, right, this is the per phase power. Per phase power. If they're asking a power in a three phase system, of obviously they're asking me what is a three phase power, right? So three phase power, POG max, three phase will be 3 times this, right? So if I multiply 3 times the per phase power, that is 15.4 into like 10 raised to power 6. So this will be 15.4 megawatt. Okay, so this will be the answer basically. This will be the answer of this question. 15.4 megawatt. That's it. Okay. So yeah, I hope you have understood this basic point. Let's solve this last question. A three phase 50 hertz 415 volt synchronous machine operates at its rated terminal voltage, delivers 15 kilowatt of the shaft output power, delivers 15 kilowatt of shaft power at leading power factor of 0.9. Okay, delivers 15 kilowatt of shaft power. It is a machine. Okay, the armature resistance, assuming the mechanical losses are negligible, determine the synchronous reactance of the machine. Okay, armature resistance per phase is 0.5. So they are asking me that if it is able to deliver 15 kilowatt of the shaft power. So shaft power basically means the power input to the generator, right? So so shaft power, right? There is a shaft power that goes into the generator. Then from the generator, right, I get the power that is coming out of the generator in this line ZS, and ultimately in the receiving end, this is the input power PIG, right? So basically here there will be few losses, copper losses, because here I have armature resistance. If I have armature resistance, that's why due to the copper losses, that's why the POG and PIG will not be same. If armature resistance is 0, if RA is 0, you will observe that we have already done this. Whenever we make RA to be 0, your PIG and POG are same. PIG and POG are both are same. Okay, if your armature resistance is 0, PIG and POG both are same basically. Okay, so both are same. So that is the thing basically over here. So now now what I can say is one more thing, mechanical losses are 0. This is known as the mechanical losses, where the shaft input goes, and due to mechanical losses, right, overall power that I get from the generator is not the same. But here, right, already they have told me to neglect the mechanical losses, so POG will be same as the shaft power. So actually in the question indirectly they have given me POG, right? POG is given as 15 kilowatts. Okay, and operating at leading power factor, so cos theta is 0.9 lead. Okay, so here POG, right, because armature resistance is not negligible, I cannot simply ignore it, right? I cannot simply ignore it, right? So what that they're asking, they asking me what is the basically the synchronous reactance. How can I find out the synchronous reactance? Interesting. Okay. So do I know the current? Yes, I know the current, right? Because this is 415. If you notice one thing here, the excitation voltage is less than the terminal voltage. How is it possible? Because it is a leading load, then only it is possible. Otherwise it would not have been possible at all. Okay, so Okay, how do I find out the this thing, right? So one thing I know, that basically POG will be equals to whatever losses that is happening here plus PIG, whatever is the input of the power that is getting delivered to the load, right? So what are the losses? Basically losses, right? If I, because I will not be able to calculate the core losses will be equals to whatever is the losses over here, right? So the losses over here is PIG plus, what is PIG? PIG is basically, PIG is this, right? This is my PIG basically. This is my PIG. So PIG is this, right? Out of which I know what is my VL, I know what is my root 3, I know what is my cos theta. Cos theta is 0.9, correct? So it is root 3 into VL. VL is 415, line voltage is 415. Cos theta is 0.9. And IA I don't know, that is unknown to me, right? So this will be, if I write down this value, 415 into 0.9 into root 3, 415 into 0.9 into 0.9. So this will be 92 into IA plus 3 into, now this, remember copper loss is IA square into RA per phase, but whatever power I'm writing 3 phase power. So in 3 phases the copper loss will be IA square into RA. Okay, I know what is RA value they have given me, that is 0.5. So this will be 0.5 into 3. So this will be basically, and what is the input, like what is the shaft power? Shaft power is 15 kilowatt. So this will be 15 into 10 cube equals to 646.92 IA plus 1.5, 3 into 0.5, 1.5 IA square. Okay, so from here I can easily find out the this value. So this will be like it is just a quadratic. So 431.28 IA minus, if I divide by 1.5 it will be simply 10 raised to power 4, that's it, equals to 0, right? If I solve this quadratic, so I will get two values of the IA current, right? It will be B square, so sorry, minus B, minus 431.28 plus minus B square 431.28 plus my plus 4 AC, because already negative sign is included. So it will be 4 into 10 raised to power 4, right? So this value divided by 2A, whole square plus 40000 whole under root. Okay, this comes out to be plus minus 475.4. So of course you cannot choose the negative one. If I choose the negative, current will be negative. So IA cannot be negative. IA has to be positive, because current will flow from the generator to the load, right? It cannot flow from the load to the generator. Load cannot supply the current, at least in this example. Okay, so it has to be plus. So if it is plus, so this will be minus 431.28 divided by 2. So IA current comes out to be 22 point, after solving this quadratic, IA current comes out to be 22.05 or 06 amperes. This is my IA current, right? So now it's pretty straightforward. Now what they are asking, they are asking you to find out the synchronous reactance. What will be the synchronous reactance? So I know what is my IA, so I can easily solve this basic equation, right? Should I solve this basic equation? I'm thinking no. Oh, let's not do this. That will be a bit difficult, right? Okay. So what is my IA is equals to 22.06 angle. What is the angle? Cos inverse of 0.9, right? It is leading, so it will be plus 25.84. It leads the voltage. So now if you remember the formula, what was the formula? One formula, right? Where the load was leading, basically the E was under root V cos theta. This was, if I remember it correctly, this was plus IARA. This will be always plus IARA plus whole square plus V sin theta minus IA excess, right? This was the formula. This we derived in the previous lecture, right? And this is very basic formula that you must remember. Okay, this is required actually. So I know what is the magnitude of E. Already is given to me. Magnitude of E is 400 volts, right? Remember, this is line voltage. This is line voltage, right? So I have to write it in phase. I will square both sides. This will be 400 divided by root 3 whole square equals to V 415 cos theta. So cos theta is cos of 25 basically, which will be 0.9 plus IARA. IA I already know, that is 22.06 into RA. RA is given to me. RA is 0.5 ohms. 0.5 ohms whole square plus this will be 4. Again I'm making the same mistake, right? Again I have to divide by root 3, right? Don't forget to divide by root 3. So this voltage is also phase voltage, right? Not line voltage. So 415 by root 3 sine theta. So sine theta, this will be 25.84 sine of this angle. So 0.436 plus IA, sorry, minus IA into excess, right? IA into excess, 22.06 into excess. This value I don't know actually. So this will go on the left hand side. This will go here. Okay, this will go on the left hand side and will be subtracted. I will calculate this value. So this value will simply be, right, 400. Let me calculate this value, right? 415 divided by root 3 into 0.9 plus 22.06 into 0.5 whole square, then subtract this plus 400 divided by root 3 whole square, and then I take the under root. So it comes out to be 44.20. This can be 415 divided by root 3 into 0.436 minus 22.06 into excess. Now one thing is, you will always choose this as positive. Why? Because I know this drop can never be greater than this drop. This always will be higher. This always will be higher than this, right? This you can go in the vector diagram, you can see this will be lower always. So that's why this, right, if I take the under root, there can be two solutions, plus minus, but I already know that this is higher than this. So this will, I will only choose the positive. I will only choose the positive value over here. So now if I calculate this value, right, this subtracted okay, this 415 into 0.436 divided by root 3, this divided by 22.06. So your excess comes out to be xs. And anyways, if you choose the negative solution, it will come out to be wrong. Okay, it will come out to be wrong. Oh no, no, it will not come out to be wrong. So negative solution you will not choose, you will choose the positive solution. By default I know this is higher than this is, right? So this will, your xs synchronous reactance is actually quite close, it is 2.731 ohms. So all formulas actually are pretty important, that formula is also very very important. Okay, so you cannot actually skip any formula. This will be the answer of this question. And with this basically we will end today's lecture. All the assignment questions have been discussed. In the next lecture we will discuss about like other topics about synchronous motor, how is the power delivery done in synchronous motor. So I hope you have enjoyed this lecture. If you did, make sure to hit the like button, and I will see you in the next lecture. Until then, happy learning.